Vanakkam. In this video, we are going to see sphere, a three-dimensional object in mathematics. I am Dr. Gnanachandra, Assistant Professor, Center for Research and Postgraduate Studies in Mathematics, Ayya, Nadar, Janaki, Ammal College, Sivakasi. This video includes definition of a sphere, equation of sphere in diverse forms, plane section of a sphere, tangent plane, great circle, as well as intersection of two spheres. First, let us see the introduction about sphere. A sphere is an object that is an absolutely geometrical shape in three-dimensional space. Like a circle in two-dimensional, a sphere is a three-dimensional space and is mathematically defined as a set of points equidistant from the center. That is, a set of points from the given point known as center and with the equidistance known as radius in the Euclidean space. So, a sphere is a result of rotation of a circle about one of its parameters. Most of the properties and fundamentals of a sphere are similar to that of circle. Okay. Here, this is a formal definition of a sphere. A sphere is the locus of a point moving at a constant distance, that is equidistance from a fixed point. That constant distance is called radius and a fixed point is called a center. Sphere is a geometrical object in three-dimensional space that is the surface of the ball. Okay, and we begin with some of the components of a sphere in this video. First, equation of a sphere in diverse forms. Here we can see there are three types of forms. One is center radius form and general form of a sphere, and the next one is diameter form of a sphere. The first one is center radius form. That is, they have given center and radius. We have to find the equation of a sphere. Okay. The equation of a sphere with the center C of ABC and radius R is given by x minus a the whole square and y minus b the whole square and z minus c the whole square equal to r square. So we can apply the value center here and radius here. And we can apply the center as origin, that is 0, 0, 0. We can get that x minus 0 square plus y minus b 0 square plus z minus 0 square equal to r square. So the equation x square plus y square plus z square equal to r square represents the sphere with the center, origin and radius r. We can apply the value or equal to 1, we get the unit sphere. Okay. The next one is general form of a sphere. The equation x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equal to 0 represents a sphere with the center minus u minus v minus w and radius square root of u square plus v square plus w square minus d. Here we can expand this using the formula a minus b the whole square and we can get this. Here the center is minus u minus v minus w and the radius square root of u square plus v square minus d. Okay. The next one is diameter form. The equation of a sphere described on the line joining the points A and B. Here A is x1, y1, z1 and B is x2, y2, z2. The diameter, so AB has a diameter and the diameter form is given by x minus x1 and into x minus x2 plus y minus y1 into y minus y2 plus z minus z1 into z minus z2 equal to 0. Shall we see one example? Find the equation of a sphere if one of its diameter has end points 214 and 4310. So there are various diameter of a sphere. So here they have given 2 points and find the diameter as well as the center, radius. Then you can find the sphere form. Okay. The first one, the center of the sphere is the midpoint of the diameter. We all know this. This is the diameter. Okay, this is the center. So center of the sphere is the midpoint of the diameter. First we can find the midpoint of the sphere. That is nothing but the center. So we have given 2 points A and B. So the midpoint is the coordinate wise addition. That is 2 plus 4 divided by 2, 1 plus 3 divided by 2 and 4 plus 10 divided by 2. This is nothing but 3 to 7. Okay, then the length of the diameter. Now we have to find the length of the diameter. Here they have given 2 points A and B. And now we are going to find out the diameter length, that is AB. This is nothing but the usual distance formula. We can apply the distance formula, that is this points x1, y1, z1 and x2, y2, z2. The distance formula is nothing but square root of x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. So we can apply the formula here and we can find the value of diameter, that is length of the diameter is nothing but square root of 44. We know that the diameter divided by 2 is nothing but the radius, okay. So radius of the sphere is nothing but square root of 44 divided by 2, that is square root of 11. Now we know center as well as the radius of the sphere. Then apply the center and the radius in the center radius of the sphere form. We can get the equation of a sphere is x minus 3 the whole square, y minus 2 the whole square plus z minus 7 the whole square equal to 11. The next one, find the center and the radius of the sphere 2 of x square plus y square plus z square plus 6x minus 6y plus 8z plus 9 equal to 0. Okay. We can compare this equation with the general equation of a sphere. So, see the general equation, here the equation starts with 2 times. So totally you can divide the equation by 2 and compare the general equation as well as the given equation. We get the value of u is 3. And V is minus 3 and W is 4. So, a center formula is nothing but in the general sphere minus U minus V minus W. So, this is the center and see the D value is here, the D is 9 and the radius formula is square root of U square plus V square plus W square minus 3. Supply this value in this formula and we can get that the radius value is 5. So, in the equation of a sphere, we can find that the center and radius. Okay. Consider a sphere and a plane that intersect it. So, we have a sphere, a plane intersect that sphere. So, what do you expect the intersection to be? The following result will give you the answer. See. So this is a sphere, look like a ball. We can intersect the sphere using a plane, okay. Then we get the circle. Yes, the result is a circle. Yep, that is nothing but a planar section of a sphere is a circle, okay. Shall we prove this? Let a plane pi. See this figure also. This is a plane, okay. The plane pi cut a sphere. So this is a sphere, the outer sphere, this is a sphere of radius or this is the radius and the center C. Okay, this is the center. Then P be the point and the plane section. We have cut the sphere using the plane and P be the point and the plane section. Okay, yes. To prove that the locus of a P is a circle. So a planar section of a sphere is a circle. So we can prove this one. The locus of P is a circle. Okay. Then we can draw take a point N in the center of the circle and the N be the put of the perpendicular drawn from C, this point center of the sphere to the plane pi, and we have to find the value of NP using Pythagoras theorem. NP equal to square root of CP square minus CN square, but CP is nothing but the radius of the sphere, therefore R square minus CN square. So this is the foot of the perpendicular, that is length, that is a value, therefore this value is totally is a constant. Hence the locus of P is a circle with center N and radius square root of R square minus CN square. And can you get this? You can intersect or you can cut the sphere by a plane if we can get a circle. So that is a planar section of a sphere is a circle. The next one is condition for tangency. So when we say that a plane is a tangent plane, okay, that is we have to find the condition for tangency. So condition for tangency is perpendicular from the center to the plane equal to radius. So this is the perpendicular from the center. This is this formula describes the perpendicular distance from the center, and this is nothing but a radius. So this formula represents the condition for tangency. Let us see through by one example. Now see, look at the question. Find the equation of a sphere with the center 1, 2, 3 and touch the plane x plus 2y plus 2z equal to 1. Okay, see the diagram. This is a sphere and this is a plane. This plane touch the sphere. This center of the sphere is 1, 2, 3. This equation, that means this equation x plus 2y plus 2z minus 1 represents the plane. So this is a plane. We have to find the equation of a sphere. Okay, center is given and the touching plane is also given. We have to find the equation of the sphere. This is our aim. Okay, first, we know that the center of the sphere is minus u minus v minus w. Already they have given 1, 2, 3. So this c is 1, 2, 3. That is u equal to minus 1 and v equal to minus 2 and w equal to minus 3. Now, using the contingency formula, r square equal to perpendicular distance from the center of the sphere to the plane. So this is the perpendicular distance from the center of the sphere. Can you get it? Yes. We can apply this formula, the value supplied to the plane, and we can get it at d equal to 26 by 9. Already center is given and d also given. Now we can v, u, w also we know that. Apply this value d and using this values we can write the equation of a sphere. So there is a simple method to find the tangency, to find the plane to be a tangent plane. That is. Okay, next one is find the equation of a sphere passes through the points 1, 0, 0, 0, 1, 0 and 0, 0, 1 and the center on the plane x plus y plus z equal to 6. Here they have given 3 points, that is a sphere passes through the 3 points and the center of the sphere is lie on the plane x plus y plus z equal to 6. Okay, yes. First let us write the general equation of a sphere and center, they have given center of the sphere lie on the plane. So we know that the center is minus u minus v minus w, that is lie on the plane x plus y plus z equal to 6. You can substitute the value x equal to minus u and y equal to minus v and z equal to minus w. We can get that minus u minus v minus w equal to 0. This is equation 2. Already we can take general equation as a sphere is equation 1. Okay. Now the sphere passes through the points 1, 0, 0. So in equation 1, we supply the points x equal to 1 and y equal to 0 and z equal to 0. We can get the first equation. As supply the points 0, 1, 0 and get this equation and 0, 0, 1 we can get this equation. So these 3 equations represents the equation 3. Okay. Now we can we can compare these 2 equations and solve and get the value of d equal to 3 and using the value d equal to 3 and supply these d value in this equation 3 we can get u, v, w. We got u, v, w and d and substitute these values in equation 1 and we get the general equation of a sphere. Can you get it? Yes. Now, the section of a sphere by a plane through its center is known as a great circle. We can divide a sphere by its center. By its center, the circle is known as a great circle. See, this is a sphere. The whole figure represents a sphere. I can cut the sphere in the center, that is middle. That is, we got a circle, that is a great circle. Can you get it? Yes, the center and the radius of a great circle are same as that of the spheres. This is the sphere of the center and this is nothing but the center of the great circle also. And this great circle is also known as orthogram and this is the largest circle that can be drawn on any given sphere. So great circle is the largest circle that can be drawn on any given sphere. Now a problem to obtain an equation of a sphere having circle. This is an equation of a circle. So sphere and a plane equation combinedly represents the equation of a circle. Here having the circle as a great circle. Okay, here they are given great circle. We have written the equation of a sphere. This is the equation of a sphere and a plane. The required sphere is the sphere plus some constant into plane equal to 0 and we can combine this one and write it. And in this equation we have to find the value of u, v, w, that is the center radius center. We found the value of center u, v, w, that is minus u, minus v, minus w, and substitute these values in the plane, and we got the value of k, that's k equal to minus 4. So k equal to minus 4, we can supply the value of k equal to minus 4 in equation 1. We got the equation of a sphere. Now let us see another problem. Find the equation of a sphere through the circle. So this is the equation represent the circle and the point through the point 1, 2, 3. We can write the first one sphere equation is so x square plus y square plus 9 as minus 9 equal to 0, and the plane is u, and the required sphere is nothing but x plus k equal to 0. So S1 is represents the equation of a sphere, that is s plus ku equal to 0. This required sphere passes through the point 1, 2, 3. Therefore, we can apply the points 1, 2, 3 in equation 1. We got the value of k, and supply the value of k in equation 1, we obtain the required equation of a sphere. So this is a simple problem. You can represent the sphere equation as s plus ku equal to 0. That is the only way. Okay. Next, let us see tangent plane. A plane is tangent to a sphere at a point P if it intersects a sphere at P only. Okay. In this case, we also say that a plane touches the sphere at point P, and P is called the point of tangency or the point of contact of the tangent plane. We already saw that the condition for tangency. So here the point of contact is, this is the point of contact between the plane and the sphere. The equation of a tangent plane is this is the equation of a sphere. The equation of a tangent plane at the particular point P of x1, y1, z1. See here, this is the point x1, y1, z1, and this is the center of the sphere. This is the plane. This plane, and we can represent the equation of a tangent plane is x1 plus y1 plus z1 plus u into x plus x1 plus v into y plus y1 plus w into z plus z1 plus d equal to 0. So this equation represents the equation of a tangent plane. Here there is another problem. Find the condition for the plane. So this is the plane equation, Lx plus My plus Nz equal to P, and where Lm and R direction ratios or direction cosines to be a tangent plane to the sphere. Here this is the equation of a sphere. Okay. In this equation we can found the, so in the sphere equation we can found the center of the sphere as minus u minus v minus w, and the radius is your square root of u square plus v square plus w square minus d. The plane, the given plane Lx plus My plus Nz is the tangent plane. We already know the condition for tangency. That is the perpendicular distance from the center is nothing but the radius. Okay. So we can apply the perpendicular distance formula. In the plane, supply the points minus u, minus v, minus w here, and square root of the coefficients of x, y and z, L square plus m square plus n square equal to radius. Here we can square it, that is lu plus mv plus nw plus p the whole square. We can take minus outside and square it. Okay. And here square root of L square plus m square plus n square, we can square this and we can get this L square plus m square plus n square and u square plus v square plus w square minus d, which is the required condition. Just apply the condition for tangency and we got this condition Lu plus mv plus nw plus p the whole square equal to this, which is the required condition. Now, another one problem. A sphere of constant radius k passes through the origin and meets the axis ABC. Okay, so this is the sphere, and this represents the x-axis, y-axis and z-axis, and this sphere meets the axis at A, B and C. Okay. And prove that the locus of the centroid of a triangle ABC. So, you can join the points A, B and C, we get the triangle. And the locus of the center of the triangle ABC is 9 times x square plus y square plus z square equal to 4k square. We have to prove the locus of a centroid of a triangle is 9x square plus y square plus z square equal to 4k square. So, let us see the solution of this problem. First, we can take the sphere equation as general equation of a sphere. the given condition is a sphere of constant radius k. So the radius of the sphere is k and passes through the origin. The given sphere passes through the origin. Apply the condition for origin, passes through the origin, and radius k. We can get the value of d equal to 0. Substitute the value of x, y, z equal to 0. In this equation, we get d equal to 0. And the radius value is k. Radius is already, we know that square root of u square plus v square plus w square minus d equal to radius. There you can apply k equal to r. Okay, and squaring that one, you can get this. In equation 1, supply the value of d equal to 0. This equation becomes this. Okay. Now, the equation of x-axis is, we know that y equal to 0 and z equal to 0. Supply the values in this equation. We get it x square plus 2e x equal to 0. That is x equal to minus 2u and x equal to 0. So, supply these values. We get the points a equal to minus 2u 0, 0. Similarly, we can find that b is in y-axis. So, equation of y-axis x equal to 0 and z equal to 0. Therefore, we get the points. Equation is, first we can get the equation y square plus 2vy equal to 0 and b is 0, minus 2v, 0. Similarly, c is 0, 0, minus 2w. Now, we found the coordinates of a and b and c. Now, let G be the G of x, y, z be the centroid of the triangle ABC. See here, this is the centroid of the triangle. We can draw the lines and meet this. This is a point of centroid of a triangle. Then the first one is x equal to, you can add the 3 coordinates, first coordinates and divided by 3, similarly y and similarly z. So for the first coordinates, u equal to minus 3x by 2, v equal to minus 3y by 2 and w equal to minus 3z by 2. So locus of centroid of a triangle is u square plus v square plus w square equal to k square, that is 9 times x square plus y square plus z square equal to k square. Here we have apply the value of origin and radius k in equation 1 and found d equal to 0, and in the sphere equation we can supply these values and the sphere meets the x-axis at A. So find the coordinates of A as well as B as well as C and then find the centroid of the triangle. So this is a procedure to solve this problem. So now let us see intersection of two spheres. The intersection curve of two spheres always degenerate into the absolute conic and a circle. The real intersection of two spheres is a circle. The plane determined by this circle is perpendicular to the line connecting to the centers of the sphere, and this line passes through the centers of the circle. See the figure. So this is the intersection of two spheres. See here. See here, this is the intersection of two spheres. So the real intersection of two spheres is a circle. We can form a circle. Let us see. This is a circle. We can intersect two spheres and we got a circle. Yes, another one problem. Prove that two spheres, here they are given two spheres and they touch each other and find the point of contact. The first one, the two spheres that touch each other and if they are touch each other, find the point of contact. Okay. First, this is the equation of a sphere, first sphere, and this is the second sphere. And the center of the first sphere is by apply the formula of minus u minus v minus w. C1 of 1 minus 2 minus 2 is the center of the first sphere. And the second one is C2 of minus 5 0 minus 1 is the center of the second sphere. And we can supply the formula for radius, that is u square plus v square plus w square minus d, and we got the radius of first sphere r1 as 3 and the radius of the second sphere r2 equal to 4. Now we found the center radius of two spheres. Okay. Now we have to find the distance between the centers, that is the first center is C1 and the second center is C2. Now find the distance between C1 and C2. We supply the formula of x2 as well as I've already first slide itself I told distance between the 2 points formula, that is square root of x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. So supply that formula and we found that C1 C2 is 7. This is nothing but the radius is the addition of two radius, that is R1 plus R2. Hence, the two spheres touch each other externally because the distance between C1 and C2 is nothing but R1 plus R2. Now, the point of contact P is the point of division of the line joining C1 and C2 in the ratios 3:4 internally, because the radius of the first sphere is 3 and the radius of the second sphere is 4. Therefore, the point of contact P is the point of division of the line joining the points of C1 and C2 in the ratio 3:4. Okay. Let us see the conclusion of in this video. The second degree equation x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equal to 0 represents a sphere with the center minus u minus v minus w and the radius u square root of u square plus v square plus w square minus t. So, second degree equation represents a circle with the center and radius, and a planar intersection of a sphere is a circle. And the equation of a tangent plane to, this is the general equation of a sphere, is the equation of a tangent plane is x1 plus y1 plus z1 plus u into x plus x1 plus v into y plus y1 plus z into z, z into z plus z1 plus d equal to 0. This is perpendicular to the line joining x1, y1, z1 to the center of the sphere. Next, two spheres intersect in a circle, that is very important, and there are infinitely many spheres that passes through the given circle. These all are the things we just saw in this video. So, any questions? You can find me at this website as well as my email ID bgchandra07@gmail.com, and my special thanks to Professor Gnanachandra and Dr. C. Parameshwaran, heads Department of Mathematics, Ayya, Nadar, Janaki, Ammal College, Sivakasi, for their support throughout the video preparation. Thank you.